Hello all. Today we're going to talk about section 6.4, example number 2. Graph with a calculator a transformed square root function. So for each of these two parts of the example, we are going to graph each function and identify the domain and range, then describe how the transformation is related to the graph of the parent function. The parent function is f of x equals square root of x. So taking a look at our first example 2, part A, g of x equals negative 3 times the square root of x plus 1 plus 2. So notice here we have a negative 3 for A. Since A is negative 3, we know this whole thing is going to be flipped over the x-axis. So let's find our domain. Remember, our domain is going to take our radicand, x plus 1, and set it equal to 0. So x equals negative 1. So our domain is the set of x such that x is greater than or equal to negative 1. And our range is going to take negative 1 from our domain and plug it into the function. So we're going to find g of negative 1. So negative 3 times the square root of negative 1 plus 1 plus 2. And g of negative 1 is 2. So our range is going to be g of x such that g of x is less than or equal to 2. And the reason it's less than or equal to 2 this time is because a is negative. So because a is negative, the range will be less than or equal to instead of greater than or equal to. Okay, so now that we know our domain and range, we can graph some points on this line. So we already know that when x is negative 1, g of x is 2. So that's one point that we can graph. And if we're plugging in values for x, we want to pick values that make our life easy. So if we're taking the square root of x plus 1, we want to put in values for x that are going to give us a perfect square so that we can multiply and add whole numbers. So I'm going to plug in 0 because 0 plus 1 is 1 and 1 is a perfect square. So when I plug in 0, 0 plus 1 is a perfect square. So negative 3 times 1 plus 2 is negative 1. So 0, negative 1. I can also plug in 3 because 3 plus 1 is a perfect square. 4 is a perfect square. So the square root of 4 is 2 times negative 3 is negative 6 plus 2 is negative 4. So 3, negative 4. It's going to be down here. And I'll plug in one more for fun. 8 plus 1 is 9. 9 is a perfect square, so the square root of 9 is 3. Times negative 3 is negative 9. Plus 2 is negative 7. So I'll go to 8, negative 7. Which is all the way down here in the bottom right-hand corner of our graph. Oh, and it looks like I accidentally misgraphed this one right here, the second one here, so make sure you edit that if you were following along. I misgraphed 0, negative 1. I put it at 1, negative 1, so we want to make sure that we have that at 0, negative 1. And then we're going to do our very best to connect these dots with a smooth curve. There we go. So our graph is going to look something like this. Now, what kind of transformations do we see? So we're going to go back to that list from earlier in the note packet about what effects the graph will have from the parent function. So if the absolute value of A is a vertical stretch or compression, depends on whether it is a number larger than 1 or less than 1. This is a number greater than 1, right? The absolute value of -3 is 3. So 3 is going to give us a vertical stretch of 3. Now, we already talked about A being negative. A being negative tells us that it is reflected over the x-axis. And the number that is in the radicand, right, x plus 1, since our original equation has x minus h, if we have x plus 1, then we're going to move 1 unit to the left. And k, the number at the end, tells us we're going to go 2 units up. Now, if you remember back to when we did this with quadratic functions, h, right, does the opposite, and k tells the truth. So if this number underneath the radical, right, this is h. So h is -1, and k is 2. So h does the opposite. So it looks like it says plus, right? So you would think go to the right, but h does the opposite. So if it looks like plus, it's going to go to the left. And k does what it says it's going to do, so +2 tells us to go up. All right, so now that you've seen one, why don't you give it a try? So pause the video here and graph g of x equals 2/3 times the square root of x plus 5. Find the domain, range, and then graph a couple of ordered pairs. And connect the dots with a smooth curve. Pause the video now. All right, let's start by finding our domain. Our domain, we're going to take our radicand, x plus 5, set it equal to 0, so x equals -5. So my domain is going to be the set of all values of x, such that x is greater than or equal to -5. And my range is going to take -5 and plug it in to g of x. And I'm going to get 0. So g of x is 0. So my range is going to be the values of g of x, such that g of x is greater than or equal to 0. Now, how do I know that it's greater than or equal to? Because a is positive. Because a is positive, my range is going to be greater than. So now I can take some x and y values and plug them into the function. So I already know that when I plug in -5, I'm going to get 0. So -5, 0 is right here. Now let's come up with some values to plug in for x that are going to give us nice perfect squares. So we have 5. So we're going to want to plug in, let's see, 4, right? 4 plus 5 would make 9. So 4 plus 5 is 9. The square root of 9 is 3. 3 times 2/3 is 2. So we're going to have 4, 2. That's right here. And the next number that would give us a perfect square after 9, we would want 16 under there, so we'll plug in 11. When we plug 11 into our function, we're going to get the square root of 16, which is 4, and 4 times 2/3 is 8/3. Now, 11 and 8/3 doesn't quite fit on our graph, but we know it's a little bit higher than 2 and quite a bit further away from 11, so we're going to have a smooth curve here that connects our two dots and still continues to gradually go upward. So now what transformations do we see? Okay, so for this one, right, our our parent function, right, f of x is square root of x. So we are multiplying by 2/3 for a. Now remember, a tells us whether it's a vertical stretch or compression. If it's a fraction less than 1, then it is what we call a vertical compression of 2/3. And we don't have a negative a, so it's not going to be flipped over the x-axis. But we do have an h, right? We have an h of 5. So this is going to be 5 units, and h does the opposite. It looks like a plus 5. So we're going to have 5 units left. And k is 0, so we're not shifting up or down. So those are our two transformations for this example. So there you have it. Example 2, graphing with a calculator a transformed square root function.